Welcome, and this is the second video in the series for the Allen Global Consulting Mentorship Program for Progress. Most programming languages and classes you take, the first thing they do is allow you to output something to the screen. It's usually hello world or this is my first program. The approach I'm taking here is to go with the structuring of programming. So we're going to deal with variables in this short video. Um, the two things that make computers very powerful is that the programs we write can run over and over again on the same data or different sets of data, and they are not emotional. They can get the same results or process the information the same um, over and over again. And one of the things that the computer relies on is the ability to store information in a very productive and efficient way. As programmers, we need to be mindful of this, and we use variables. So, uh, specifically in progress, these variables are built on top of C, and they have their own internal class structure that we use powerfully in this 4GL language, which is almost like writing English. Um, so let's start. So what I did is I launched my desktop, and then I launched my procedure editor. This is an area where we uh, typically write our programs, our flat programs, and we're going to get very familiar with this. It's like writing in Word. The only thing there's um, rules to how you instruct the program in the language. That's usually called syntax, and um, also we have to be mindful of how we name variables because it makes it more readable, so that other people can know what your programming is doing and help you if you fall into any problems. Yeah, programmers take issue with that sometimes. Well, it's my program, and if I only understand it, means I have a job forever. But that's a whole nother discussion. So the easiest variable to start with is logical. If you ever take any basic computer courses, they tell you, computers are really founded on ones and zeros, yes and no's, right? So therefore, the easiest variable is called logical. I'm going to just do DVL. So it's saying I want to define a variable, and I'm going to call it log test. Um, this way, in my naming convention, I'm letting people know that this is a logical variable, and it just happens to be test. Now, logical variables tend in progress to be uh, true, true, false, and yes, no, right? Uh, and if I check the syntax on it comes back and tells me everything is okay. There is the ability in progress to format um, the what appears um, uh, for values, and we can um, set that here. If we can do that. Uh, so when I to run this, it actually says no. What if I do it as a display. I see it saying that log test is off because the last one I have it before was no. And if I comment out and have it as a yes, it'll say it's on. So we have the ability to um, format or have it show as the value that we want it to be. So those are logical values, and obviously those help us make decisions. So we can say then we can do one thing, otherwise or else statement we can do something else, right? Right. So we're saying if things tested out as yes, then it's good. Otherwise, it's bad, right? And we see here that it says good. If I change this, it's going to tell me it's bad. All right. So that's logical field. So we're gonna move on. The next thing that computers really like to store are numbers because basically binary is just the expression of numbers in ones and zeros. So that's the next step up. So when we talk about numbers, we categorize those in computers usually in two different ways, right? We have what we've done if you take any math algebra course, what we call integers, which are numbers that are either positive or negative, and they're whole numbers, right? So we can define as integer, and you also saw there was some other ones there. Uh, there's also now an integer 64, right? And the other numbers that we're used to in our everyday moving about, especially when we're talking about money, which is a very famous one, would be decimals. Okay, so as I'm typing, I'm thinking the values to put, and there we go. So a very common use for integers are counters, right? Counting 1, 2, 3, 4, 5. Um, uh, so these things have a limit. So an integer um, is a 32-bit value. So it has a limit of about 9 spaces, 9 whole numbers, uh, positive and negative, and it can be expressed as plus or minus 2.147 times 10 to the 9, right? That's a pretty large number, but you need to be well aware that there are limits. Whereas the int64, right, as it suggests, that's a 64-bit. So it's twice as large, but it's really more than twice as large if you know how exponents work. So this guy has an expression value of 9.22 by 10 to the 18. Um, and then, sorry, this guy here. And then the decimal um, can have up to 40 spaces before the decimal and 10 spaces after the decimal. So what I'm going to do is provide you guys with a cheat sheet, and it would be probably a Word document where um, the things that are critical to understand about variables will be in there. I just wanted you to see them. So yeah, the values, so values like this would be in there. And there's also typecasting. So if you, because this only takes whole numbers, if you decided to put something like this in the counter variable, and you'll notice I'm ending all my statements with a period. That is how Progress denotes that it can consider that a complete sentence, if you will. What you'll see is it decided that this is doesn't have a value of 65.78. It has a value of 66 because when we defined counter, we said it will only hold um, integer numbers. So the computer said, well, what I can do with that is round it down or round it up. And if it's greater than 0.5, it rounds it up, and if it's less than, it rounds it down. You can change those rules. There are keywords um, such as round and down in other languages, and in this one also. And you can also typecast, which people, if they're familiar with C or Python, you would have to do. So you can, the way you would have done that in another language would have been to put this first to make sure that it came as an integer. So this is a function called integer or int. And the nice thing about Progress 2, it accepts shorthand so long as it's unique to that keyword. Um, so that's how you would typecast a value into an integer, and likewise there's one for decimal. Um, so that is numbers, and then the next variable type we will touch on. My mouse is interesting. Is dates. So for Progress, there are actually three types of date variables, and yeah, this one being the most prominent, which is simply a date. So okay, and then we'll go that way. Okay. And then there's also date and time with considering time zone. I won't look at that right now, but there are functions that are associated with this. There are keywords, today, now, m time, and time zone. Those are the main functions we use with with date and time functions. There is no single time definition in progress, but the most common we use is actually an integer. So if I define an integer, time, uh, the way how progress keeps abreast of time is seconds or milliseconds from midnight. So that's why it also offers the time zone, because in the new global economy, it is important to have the time stamp relative to where you are, and also to have a timestamp relative to where something might end up. So it has become necessary to not only record the time, but also what time zone that time was recorded or needs to be projected to. Um, so once I did that, you'll have to do something strange, like I just use stuff like this all the time. So Progress innately knows that it's formatting this in hours, minutes, seconds, and it's in military time. So that's the current time on my computer in my time zone. Okay. So then, yeah, recording a date, because my system is set up in the US, it is right month, day, year, right? That's not my date of birth, obviously, but I'm just giving you an idea of how it would look. And if we display that, it'll display just as it is, or in the shorthand version. Let's see what it does. I'm just running this. And yes, you see, it did display it in the shorthand version here. Progress takes the initiative on some things, and sometimes we don't want it to do that, so we would tell it this is a good way of showing casting. We can do it here by telling it, I don't want you to perform it shorthand. I want you to show it as I gave it to you. And you can see this value as now. Another way of maybe approaching that would be doing it here also. Let's see what happens. No, it still did it. It still put it in the shorthand there. Alright, well, we know we should cast. So this one records as seconds from midnight, and then we have M time, which is milliseconds from midnight, and you have to cast that as an int64. We can do mathematics on dates. You can add intervals to dates. To date time, you have to use a function called add interval. But with simple dates, you can add 34 days, and it will do the math for you and make sure it follows the rules of the calendar. There you go. I didn't use M time correctly. There we go. So by adding 34 days, it went out and used the right calendar rules and came back with a date 34 days later. Okay. So then, to make this video brief, the next type of variable is the most used in today's programming environment, which we all call strings, right? Words, because the human beings in our complex business world today, we have so much information being generated over the internet and over commerce, and most of it is in text form or strings. So in progress, uh, these are called, it's called a character. So like on your keyboard, a single um, visible symbol is what we would call a character. So we do VC. So I usually start mine with CH, this string, right? Okay. So we can also format strings, and I can say X means general, and you could also look up these things. Oh, maybe I'll do that now. So for instance, if I didn't know what this meant or defining a variable as car was, from here you can go to help, or from, I have selected the word and I'm going to hit F1 on my keyboard, and that is going to bring up the progress help interface. And here it automatically found the first entry for character. Now it talks about character types, and you can read about character types and what functions. Actually, this one shows you all of the types, so this might be worth taking some time to look at. There's a lot of stuff in here that you might not want to know or don't need to know, but we definitely can come and get some help uh, for what we need. Um, all right, so basically, anything goes as far as this string is concerned, because I gave it a full 80 character set, and all right, all right, and do this. And that would be the equivalent to hello world, right? That's how we can relay messages on the screen and this sort of stuff. You'll see me using a lot of my own explosive macros or jump starts. They call different things in different languages, um, but some of them come already with progress, and then I have my own shorthand that I shared most of the programmers that I work with, and I will probably do the same with you later on. Strings are a lot of fun to play with because there's a lot of functions that manipulate strings, and people understand that manipulation, and it's visible and that sort of thing. We will take the time to do some of that because it's important to have the mindset of how a language deals with information. The way how Python deals with information is more in a list form and not in an actual human interaction natural form like progress does. I think that's one of the reasons why progress to me is a very powerful thing and wonderful thing. The last but not least variable type we're going to look at are pointers. Now, you usually take a data structure class before people start talking about pointers, but it's simplicit in its simplest form. It is a memory location, or the beginning or first memory location for an object, a class, a variable. And computers have to use them. And without going through the data structure class, the computer has a list of all the positions where it had to store information, it had to process information, it had to build lists. All of those things are kept in a memory pointer table. And so most of the time people talk, the heavy programmers as we call them, talk about memory pointers all the time. In progress, we have 1, 2, 3, 4, 5. We have 5 major memory pointers. And I'm going to show you what I think is one of the best ones. And it's used when we're dealing with databases. So what I'm going to do is pull up an Excel document that I created specifically to show you about these memory pointers. This Excel document is representing a small database for customers. It has this column called row ID, this column called rec ID, this column called customer sequence, which we'll get into when we get to databases, a first name, a last name, a suffix, and a date of birth. Now, what would happen is column A and column B are defined by the progress database. Column C is a sequence that we should assign to a database so that each record has a unique number for us to reference. And then the other fields. So progress uses these two codes and numbers in the background to identify unique records across a database. And that's what makes it powerful. If I happen to want to get to John Spade's information, I could either use the sequence ID, which hopefully we design in every table, or the reference rec ID or row ID that Progress has in its list of memory pointers. So it's a very powerful tool. I just wanted to show you that. So the memory pointers in Progress are, you have row ID, you have rec ID, you have mem pointer, and my personal favorite, handle. So handles are directly dealing with objects and attributes of classes in Progress. So you can have a handle to an object, you can have a handle to a class, you can even have a handle to a method or an attribute in a class. So their handles tend to be very critical these days. And there's also another memory pointer called raw. And basically, it's Progress' last ditch effort to say, hey, we might know nothing about this object or what you're trying to do, so we're gonna just try and read this class, this object, this whatever you just created, and pull the information directly to a location without trying to read it or try to understand it in any form or fashion. RAW is generally used when interfacing with hardware devices because each manufacturer device has their own proprietary software, and sometimes they don't want you to understand some of the coding behind it, so they send you uh, big objects of all types of things and don't tell you what they do or how to do it, and just leave you on your own. And RAW is a good way of handling those things. I am going to stop here for now. Well, no, let's talk about scoping of variables. The other thing about progress is variables have a lifespan, okay, or a scope. You'll hear people talk about scoping a lot. Scoping usually talks about transactions, and a good programmer tries to reduce the scope of the transaction because the longer something is left running, the more likely something can go wrong. Um, Variables, we don't think of variables lifespan or scope the same way, but I've come up with a naming convention for my programmers of how to deal with this stuff. It's not the way Progress talks about it or even how some other programmers will talk about it, but these are the terms we're going to use between us so we all understand what we're talking about. So the first scope we're going to talk about is called session global. So, for all intents and purposes, when I'm using this editor, anything I write inside of it lives whenever I'm running. And then anything that I call, if I call another program from here, that becomes a child of this first running program. Okay, we need to understand that concept, and most people now who are into objects understand the relationship between parent and child. Okay, so we have this first program, and I could use something like run the next program, right? And next program itself can call another program. So then this first program would be the parent of next program, and the next program would be the parent of the other program. So once I define a variable here, if I just say define variable ch test, ch test would have uh, what local shared scope to this entire piece here. If instead I say define var character, define variable new global, what I'm saying here is, I should call this sesh glch. This is a session global character called my location. So technically my location isn't going to change while I am calling different programs as I go. So once I've defined this new global shared program, it means, sorry, variable, it means that any other program that is called while this program is available can use this variable. So inside, let's do that. So if this is my program, and so if this is the program next program.p, I can say us programmers tend to be lazy, so I'm just going to copy it. I'm going to say define define shared variable. Yeah, define shared variable. Okay. So this is define global shared. Okay, there you go. So once I define this here, if I change the value down here, when I come back here, it will be known, right? And then any program along the way. So if this guy is next.p, if I define a variable here, my car rental, I'm defining it here, so it would only be available to any run program that is called directly from next program. Um, so while this is alive and it's called from here, only people in its family down generations from this next program could ever use family GLC My Car Rental. Whereas session GLC My Location can be used by any program that is called from here and from here. It can go down through all the generations. And this guy stops here. It cannot go, this parent program will never be able to know the current value of my car rental, right? So that might be a little confusing, so I'll go over it again, and it will be in a cheat sheet. So we have a session global variable, which is as long as the program that the variable is declared global in is alive. Uh, any other program created or called in that session can know about that global variable by asking about it as shared variable as it goes along the line. Family shared variables will be variables that are defined not as global shared, but as new shared. And then it is only access to siblings, oh, sorry, not siblings, to children of that program. Okay? the defining program. Then you have local shared, meaning this test variable is locally shared. And we're going to talk about procedures next. So I'm just going to define a procedure. I just call it internal procedure temp. Because this is local shared, I have access to test here. But in this procedure, if I define a variable and I try to access it outside, okay, and I try to access it outside of that procedure, it is going to tell me I have a problem because the lifespan or the scope of this variable is restricted and localized to this procedure. Okay, so again, scoping, it takes a while because we want to get it right, so I'll go over it again. We have global scoping, which means a variable can be accessed. It doesn't just have to be a character, it can be any type of variable. New global shared variables are accessible to any program, any object in the current session that you're running. Then we have family shared, meaning that any program that declares a new shared variable, any of its children have access to that variable. And then we have local shared, meaning that the scope is for that object and that program. And then we have local, or what some other codes might call private variables that can only be accessed within a very limited scope. Well, I hope that gives you a lot to think about. I will try and get the cheat sheet together and start working on the next video, which deals with procedures and functions. And once we have that down, we can really start having a little bit of fun coding and seeing what this language can do and how you can start expanding your mind and using the language to do some great stuff. Thank you and have a great one.